Okay. Assalamualaikum warahmatullahi wabarakatuh. In this time, we are from Group H with the title of our research is Evaluating Implementation of 5G Dynamic Network Slicing on Public Area Wi-Fi using NS3 Simulator, which is our group member is Mas Muhammad Fareza Asrofi, Mas Dimas Prayogo, and me, Nur Anissa Kadarwati Febriani as well. Next, and the outline of today presentation is what is network slicing, and the second topic is knowing our research from the uh, background studies until the uh, result of the research. The first one is what is the network slicing? Network slicing is a concept in the context of 5G and beyond, which involves the creation of virtual, customized, and isolated network segment with a single physical network infrastructure. And benefit of the network slicing is you can do the customization and service isolation, you can do resource allocation, security and isolation also, and dynamic adaptation. Also, you can customize the quality of service of each slice, and you can get the efficiency and cost saving because you can customize the quality of service each the slicing, and it can provide you a scalability. And next, this is the method of network slicing. In our research, we just do the URLC with non ultra reliable low latency service, which have a benefit in public safety, remote surgery, vehicle to pedestrian or V2P, vehicle to vehicle or V2V. But the method of network slicing itself, it's contained of three method is which is EMBB or extreme mobile broadband, which used for video calling or virtual meetings, or you can use it as video monitoring, something like that. And the second one method is massive scale communication or MMTC, that we usually use in daily as the wearable device, just run networking, healthcare monitoring, and etc. And the our research, which the main topic is network slicing, with the main source paper is the 5G network slicing for Wi-Fi networks. This is the link, and the improvement of this the last research and our improvement is the is it before and after, something like that. And in the before, we the paper implementing static and dynamic slicing, and the environment of simulation is room with one access point with three network slicing, and each slice performing EMBB, MMTC, and URLLC. And the outcome of the uh, paper is analyzing and comparing performance result between dynamic and static network slicing. But in our research, we implementing only dynamic slicing, and the environment of simulation is wider room with one access point and one network slicing, which is dynamic slicing, and the slices performing only URLLC. And the outcome of our research is analyzing the performance results of dynamic network slicing itself in the new scenario, something like that. And for the research methodology, please have your time, Mas Dimas or Mas Reza.
Okay, thank you, Mbak Nura, for the explanation. I will continue the explanation about our research. In this part, I want to explain about research methodology that what we use in this research. First of all, we do literature review, and then after we got some paper in our previous paper is 5G network slicing, we do some research again about the trend and about the what is the new research in the world right now. After that, we conclude with the new product idea. After that, we design the topology and the function. Of course, we do some improvement from our previous paper, and then we analyze the previous source code from the previous paper. We do some improvement in our source code with our purpose of this research is about to continue the result about the dynamic network slicing in your LCC, and then after that we simulating the source code after we implementation. We do simulation in NS3. Okay, next. Okay, as you can see in the right in picture in the left about our network topology. In the building topology, we do some improvement for the width and the length. For the width itself, we do some improvement from 10 meter to 20 meter, and then for the length, we do some improvement from 20 meter to 40 meter, and then we implement one access point in this building, yeah, or room, and then we do implement then make network slicing is URLLC. Okay, in the table in the right, we do some improvement in some parameters such as NSTA. This is for the station itself, and XYZ max, this is for the building itself, and then data rate C, this is for the data rate in where LCC. And then the pilot itself, the pilot is in byte, yeah, Zeiss in Zeiss byte, and then the simulation time, we do simulation in 15 repetition, and then for the band that we use for the access point, the standard is 5 gigahertz. Okay, next. Okay, for the next part, we'll continue to Mas Reza. Thank you.
Thank you, Mas Dimas. So I will explain the result of the simulation. Here is the result of the experiment. We have 3 experiments. For the first is the experiment that we try to run the default parameter from the previous research that use the 2 random station for slice A, and then 100 number of station for static station, and then 6 station for the walking station. So we can see that the latency for the first experiment show the latency is around the 20 millisecond, and then the packet error is so very little. And then in the second experiment, we have the improvement to change the parameter of number of station and the large of the area. We can see that for the latency is have no change from the previous research, but the packet error have the increase from the previous research. So we try to change the data rate for third experiment. We can see that the packet error probability is still no change, and the latency is have no change. So we can conclude that the dynamic slicing for URLLC have the steady latency, but for the packet error have the change. Next. So for the future work, since the result of the packet error and latency is still not good after the adding the number of station and area, we suggest to adjust the coding scheme for dynamic slicing algorithm. Example for data rate, MCS, and the GI.
Okay.
So, Mbak Nura,
Okay, this is our presentation for our research. So the next part is to the simulation, but unfortunately we cannot present how our research going, because is each time we do a simulation we can take almost 15 or till 20 hours for each simulations. So the things that we can share, that first, how our simulation works. In our research there is a three code. The first code is Wi-Fi dynamic, but in the Python. The second one is the dynamic, also the dynamic slicing, but in C++. And the third one is the data processing code that convert the result of our simulation into the graphic that shows in this slide, something like that. So the two code, the Python one and the CC or C++ one, will going together and make an CSV or a data that we will process in the third code, something like that. Maybe if you wanna see the CSV, maybe Mas Reza or Mas Dimas can help me to show it, because we cannot show it the simulation. I think so. Kind of like that. Okay. For where is the data? I think from this files. Where's the CSV? Awesome. Oh, okay. Okay. So you can see, as you can see, this is our result of simulation. Just it's like it's up to maybe 1,000 more 1,000 data in here. So we process this data to be a graphic with another code called plat, I think plat CC or something, just kind of like that. So that's all for our presentation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.